So for today, so far we've gotten two rules, okay? From section 7.3 when it's come to exponents, and we focus on our zeros and our negatives. That's what we taught on Friday, that's what we reviewed during 5th grade today, and now we're moving on to these new ones. Now, the notes are set up as such that we would just give you the rules and we do the examples, but I do believe, for a couple different reasons, that it's important for you to see why these rules work. So then you can see, like, this isn't magic that somebody made something up and it just kind of works out the way it's supposed to. There's a reason why the rules that we're going to talk about today actually work. Okay? So, in order to do that, we've got to go back a little bit, kind of, to our definition of a power and everything else. So if I told you or asked you, what does it mean to have a cubed? What's that? Multiply a by itself 3 times. Okay? So a to the third power is a times a times a. Alright? And if I asked you, okay, if we know that a to the third power is a times a times a, what would that mean that a to the 5th power is? A times itself 5 times. So a times a times a times a times a. Okay? So one of the ideas that we're going to talk about today is this. What if I take a to the third power and I multiply this by a to the 5th power? Now, ideally, we'd like to be able to do this pretty quick and not have to write these out all the time, but for you to understand where this rule comes from, Adam, can you put that away, please? If we want to understand where this rule comes from and how it is involved, I think it's important for us to go back to the basics here. Okay? If a to the third power is taking a times itself 3 times, and a to the 5th power is taking a and multiplying it by itself 5 times, what happens when we multiply those two things together? Well, when you see it written out like this, what you're going to notice is this is just one big long multiplication problem. And it's not just one big long multiplication problem, it's a multiplication problem where everything that is being multiplied together is the exact same thing. They're all a's. So, if I'm repeatedly multiplying the same factor over and over and over again, I should be able to condense this down into an exponent problem. What is being multiplied together here? A's. How many times are we multiplying all of these a's together? A total of 8. Which means that if I were to take a cubed and multiply that by a to the 5th, that should, in essence, just become a to the 8th. So, our goal is this. We'd like to come up with a shortcut rule that allows us to go from here to here and not have to write this out all the time. Because let's face it, if I gave, like I picked 2 relatively small exponents right here, so it wasn't terrible to write them out. But if I said, what is a to the 13th times a to the 23rd, I really don't think we want to write that out, do we? Okay? So that's why this rule is going to be important. This is the rule that we discovered last year. We discovered that if you're multiplying 2 powers together, and here's an important thing, and they have the same base, this only works if these are the same variables, what are we ultimately telling somebody we're going to do? You're going to add your 2 exponents. So you're going to take the 3 and the 5, you're going to add those 2 together. That's what's going to get you your new exponent of an 8. Now again, this doesn't work if it's a to the 3rd times b to the 5th. That doesn't work anymore. Because that would be a times a times a times b times b times b times b times b. So some people will be like, well, what's that equal then? It's this, and that's it. There is no way that it can be simplified anymore. Okay? So, our first rule that we're going to discuss today and get jotted down to our notes is what we call the product of powers. Why do we call it the product of powers? Because we're taking two powers and we're multiplying them together, which the last we checked, that was the word of product. So, here's what we're going to add into this. 2 multiply powers with the same base. This is a key idea here. They must be the same base. Add their exponents. To multiply powers with the same base, we're going to add their exponents. And I'll give you an example of it, kind of just using variables. If we had x to the m, and that is being multiplied by x to the n, this will become x to the m plus n power. Now, 2 things to be aware of. Number 1, as I've said before, and it says here, this only works if they have the same base. And number 2, after we combine these 2 together, we are still going to have to worry about, from what we learned on Friday, zeros and negative exponents. Okay? So, if you think about what we learned on Friday, we said that there were 2 rules of exponents at this point in time. And rule number 1 was no zero exponents. What was the second rule we learned on Friday? No negative exponents. Alright, so as you went through on your homework on Friday, that's what you were concerned with, right? Our new rule today that we're going to add to this is no like bases. And when we say no like bases, ultimately what we're saying is you can only have the same variable, you can only have a variable show up once in the problem. So I can't be left with 2 a's in a problem. It's not going to be allowed. We need to be able to combine those together. I'm not going to be able to have 2 x's. I'm not going to be able to have 2 y's. Now, can I have an x and a y? Yes, because those are not like bases. Okay? But I'm not allowed to have 2 of the same variable in the final answer. Okay? So, let's take a look at these. And these first ones are not very complicated. They only give you 1 variable, so we just kind of work through that. We are multiplying 2 to the 6th times 2 to the 8th. Now, here's the thing. When I see these problems, and students do these problems, they actually do better with variables than they do with numbers. Okay? So, notice that in this rule, when I multiply x to the m and x to the n, my base doesn't change, only my exponents do. So when I'm taking 2 to the 6th, and I'm multiplying that by 2 to the 8th, do I actually take 2 and 2 and multiply those together to get 4? No, we don't. The base here needs to stay the same, and it's going to have to stay as a 2. What is going to change is the exponent, where of course we're going to add those 2 exponents together, and I add 6 and 8 together, and I've got 14. So this now becomes 2 to the 14th power. Okay? This one sometimes throws us off. Okay? We have the same base, -3 and -3. So those 2 are being multiplied together, which should allow me to add my exponents. But here's what throws people off. They don't see the second exponent, so when they go to add it, they just add 7 and 0 to get 7. Well, it's not a 0. What is that second exponent? It's a 1. So if you need to, and this is sometimes a habit that students get into that's actually not a bad one, they put that 1 there. So if I take negative 3 to the 7th power and I multiply that by negative 3 to the 1st power, this should become negative 3 to the 8th power. Now you might say, Mr. Tompkins, are the parentheses important? My answer would be, let's find out. Everybody's got the calculator handy, right? Take negative 3 to the 8th power with parentheses, like it's written right here. And find out what you get for an answer. 6,561, right? Now, do it without. You got a negative. So do the parentheses matter in this problem? Yes. Parentheses are always going to matter. Make sure that when you're doing evaluating problems that involve numbers, which we're going to see quite a few of those, if there's parentheses in there, you need to include them. If there's not, then don't. But if the problem includes parentheses, you need to make sure that you include them when you do your work. All right. Now, we slide down to example C. We have three things being multiplied together. Those three things all have the same base of m. So what do? We add together all their exponents. So when we add those three exponents together, what do we get? We get 12. Why aren't we getting 11? There's a 1 right there. And if we take 1 plus 5 plus 6, that gives us 12. That's where we're going to be left with m to the 12th. Now, here's really before, as long as we're on the topic of like zero exponents, here's what I like about exponents. Like everything fits. It's not like we make some rule up that doesn't work. So what if one of those was a 0? I want you to view it like this. What if I gave you x to the 0th times x to the 11th? If we use the rule that we just learned, what are we doing with those two exponents? We're adding them together. And what's 0 plus 11? It's 11. Now, if we use the rule that we talked about on Friday, what is x to the 0th power? It's 1. And what's 1 times x to the 11th? It's x to the 11th. The rule that you're learning today actually just confirms the rule that you learned on Friday. Anything raised to the 0th power should be equal to 1. And that's what I like about these is they start to they all jive in together. They're not contradicting one another. Well, I got to do it this way or this way or this. It doesn't matter how you do it. You still end up with the exact same answer. Now, when we get to letter D, some people are like, well, but now there's a negative. Yes, there is a negative. But I'm not going to worry about a negative until I first of all take care of this. So I'm going to tell you this. I worry about zeros and negative exponents if they end up in my answer once I've done all the other stuff. But if they don't end up in my answer, then I don't need to worry about them. So some people are like, well, should we move the y to the bottom? No, I wouldn't. I would leave it exactly where it's at right now. Okay? We have a y to the negative 2nd and a y to the 8th. Again, those two are being multiplied together, so what do we do with the exponents? We add them together. And if I take negative 2 and I add 8, I get what? We get 6. Do I have a 0 or negative exponent anymore? No, that's it then, that's it. So I'm not going to worry about the negative that was in the problem, because when I added together my exponents, it became a positive and it was fine. Now, what if I added those two together and I got y to the negative 6th as the final answer? We're going to just move that to the bottom like we did last week, and we'd have 1 over y to the 6th. So, we still have to use our rules when necessary, but I'm not going to use them until I've already combined like bases first. Okay? Does that make sense on this one? Now, on your homework tonight, you'll see that there might be 2 or 3 variables in the problem, but again, you're only looking for things that have the same bases in order to use this rule. Alright, next one. And again, I want to give an example of what this is before I tell you how it works. This is new. This is one we did not see last year. So, what if I gave you a problem such as x to the 8th cubed. Here's an example, and you're going to hear me say this phrase a lot. This is a power to a power problem. Now, what does it mean to cube something? Multiply it by itself 3 times. So this is exactly what I'm going to do, is I'm going to take x to the 8th, and I am going to write this out as being multiplied by itself 3 times. Now, am I going to do this all the time? No. But we're going to do this so we can learn what rule we're going to be using. Now, what's the purpose of writing it out like this? Because we just learned this rule, the product of powers property. And the product of powers property says that if I'm multiplying together powers that all have the same bases, what do I do with the exponents? We add them all together. So when I add my 8 and 8 and 8, that's actually going to give me what? It's going to give me 24. Again, our goal is to be able to go from here to here without this middle step. So, what do you guys see is happening? We're multiplying. Okay? This power to a power, those two things are being multiplied together to give you your 24. That's not 8 to the 3rd power. Some people will do that. They get an answer of 512 and they think that should be their new exponent. No. With the power to a power, you are going to multiply your exponents, not actually do the exponent problem. So, here's our example for this one. So, to find the power of a power, multiply their exponents. So for our example on this one, I'm going to say that if we have x to the m raised to the n power, power to a power, this will become x to the m times n power. With a power to a power, you multiply their exponents. Alright, so in letter A, it's exactly what we have. 3 to the 3rd is a power being raised to another power, in this case to the 6th. I need to multiply together those two exponents, and this is going to become 3 to the 18th power. That's it. That's your work. That's everything. You're using your rule to shortcut it to that. Okay? -12 raised to the 7th power raised to the 5th power. Well, with the power to a power, those are going to be multiplied. So I'm going to end up getting -12 to the 35th power. We're not going to ask you to evaluate that because it's going to be a huge number. Okay? With letter C, we have d to the 5th. That is being squared. So with a power to a power, we multiply. This becomes d to the 10th. Miles, question. And that one, oh, sorry, I didn't have that. Yep. Oh, the reason, you know what? I don't need parentheses there. Sorry. Now, letter D, and I'm throwing this one at you, previewing a few weeks down the road. Okay? If you recall, when we took find what a exponent was, or a power problem, we said that it was an expression raised to some power. So my x to the, or x minus 3 is like a 12. It's like the 3. It's like a d. It is the base of my problem. Okay? This is going to stay in parentheses. Then, this is being cubed, then to the 4th power. So with this power to a power problem, we're going to multiply those two together. You're going to have x minus 3 in parentheses raised to the 12th power. Okay, again, it won't always be a number and a variable. Sometimes it'll be a number, variable, and an operation with addition or subtraction. Okay, like I said, this is, after spring break, this is what we're going to focus on. Our problems will look like that a lot. We're going to graph them, we're going to factor them, we're going to solve equations, we're going to get into a lot of stuff that deals with those. Alright, so there's property number 2. We need to talk about property number 3. Now, property number 3 is similar to property number 2, except we're going to now add in something more than just a number or variable. Okay, what do I mean by that? I'm going to give you an example again, and then you'll see, we'll jot down our explanation for it. If I gave you 3x to the 5th, and I asked you to square that, okay, our first property that we just got done looking at said, what if I just have x to the 5th squared? Or what if I just have 3 squared? Now I've got the whole thing here. Okay, so we got to know what we need to do in this particular problem to guarantee that we're going to get the right answer. So again, what does it mean to square something? Multiply it by itself. So let's write that out. That means that this is equal to 3x to the 5th times 3x to the 5th. So we're actually going to be using our product property here. Now, my 3 and 3, there's 2 of them, there's not just one of them. Those two have to be multiplied together. What's 3 times 3? It's 9. Now, these are both like bases, which we're not allowed to have in a final answer. Those like bases are being multiplied, so what do we do with their exponents? We add them in. 5 plus 5 is... So this final answer becomes 9x to the 10th power. Now, for a lot of students, they're like, well, I understand where we got 10 from. Where in the world did you get your 9 from? Okay? Here's where. Think of this as a 1 right here, because it is a 1, isn't it? This exponent outside the parentheses goes to every piece that's inside my parentheses. So this is a power raised to a power. This is a power raised to a power. So really I have 3 to the 1st being squared, and I have x to the 5th being squared. Does that make sense to everybody? Now, what do we do with the power raised to a power? We multiply 3 squared x to the 10th, and that gets me 9x to the 10th. By far, the most common things that students don't do right on that one is they don't take the exponent with the number as well. Okay, it goes with everything that goes inside the parentheses. So, let's take a look at this rule. To find, again, this is a power of a product, not of an addition problem. These two are being what? What's happening between my 3 and my x to the 5th? Multiplication. This is a product, and we have a power of a product. Okay? So here's what it says. To find the power of a product find the power of each factor and multiply. gentlemen, that's what we did right here with our example. We found the power of each product, or each factor, and then we're multiplying those two together, okay? Here's our example. This one's going to have a lot of variables, okay? But I want to make sure that it kind of covers everything that we need here. If we had x to the m, y to the n, and this is being taken to the p power. So I have two things inside my parentheses being multiplied together. And there's an exponent outside my parentheses. This will become x to the m times p, y to the n times p. Everything that's inside the parentheses gets that exponent that is outside my parentheses. Alright, so let's take a look. First of all, what's my exponent on my 16? 1. What's the exponent on my 21? All 1. So what's going to happen is this 4 is going to go to each of those. Now, why does it go to each of those? Because these are being multiplied. I'm going to tell you right now, if these are being added, that rule doesn't work. We don't have the we don't have the power of a sum property. We have the power of a product property. Okay? So, you might not get used to this for a little while, but I'm going to write it out like I wrote this out. I have 16 to the first raised to the fourth times 21 to the first raised to the fourth. Alright? Again, what do we do with power raised to a power? We multiply. So this would become 16 to the fourth power times 21 to the fourth power. Okay, how many things are inside my parentheses in the letter B? 3. All 3 of those need to be taken to the third power. 6 to the first raised to the third, m to the first raised to the third, n to the first raised to the third. Okay, again, what do we do with power raised to power? We multiply. 6 to the third, m to the third, n to the third. Now, we're going to ask you to simplify, so I need you to start to get in the habit of doing this. Take your numbers and actually start to evaluate. What is 6 to the third power? 216, m to the third, n to the third. That's going to be my final answer. 216, m to the third, n to the third. Good so far? Alright. Let's slide down to example C. How many things are inside my parentheses? 2. Each of those 2 items should be taken to the third power. So we're going to have -5 to the first power, then cubed, p to the first power, then cubed. And again, with power to a power, we should multiply. -5 cubed, p cubed. Okay, I'm going to ask you to evaluate that. What's -5 cubed? -125. Did the parentheses matter in this problem? Actually, they don't. With or without parentheses, this is a -125 raised, times p to the third power. Now, letter D. Please pay attention that there's a negative in front of the parentheses, not inside of it. So, when this gets distributed through, and I rewrite this, I'm going to put a -1 out in front because that's where that negative's at, isn't it? Then we'd have 2 to the first power raised to the fourth, q to the first power raised to the fourth. Everybody good with that so far? Okay? Power to a power, let's multiply. Now, this is why this is so important. Okay? I want you guys to practice this on your own. Use parentheses. Take -2 and raise it to the fourth power. What do you get? You get 16. That's not what we're supposed to get here. Because according to this, we're supposed to take 2 to the fourth power first. What's 2 to the fourth power? 16. What's 16 times -1? -16. This negative in front is completely different than if the negative was inside. We have to understand that there's a difference there. -16 cubed to the fourth. That's my final answer. Again, if I would have thrown the negative inside of there, my final answer would have been 16 cubed to the fourth. There is an important difference based off of where that negative is at. Alright, good so far. Because now we're going to wrap it up and we're going to throw everything into one. So let's take a look at example 4. These A, B, C, Ds. By the end of today, you should be able to do these that I'm going to give you right here. Now, you might say, where do I start? Think order of operations. You're going to have to do this exponent before you multiply, right? Because in PEMDAS, E comes before M. So, we're going to need to get this 3 through that set of parentheses first. So I'm going to have -3 to the third power. Y to the what? Nope. Y to the 15th power, because that power to a power gets multiplied. Then I still have behind this 2y squared. Okay? Now, I need to evaluate. What is -3 to the third power? Negative what? -27. Y to the 15th times 2y squared. Everybody good so far? Now, we can actually do the multiplication. We just got done doing our exponent, didn't we? Now we're going to multiply. So we multiply together like terms. What's -27 times 2? -54. What do we do when we multiply bases? Add our exponents. -54y to the 17th. Do you have any zero exponents? Do you have any negative exponents? Do you have any like bases? Nope. That's our final answer then. You still have to make sure that the 3 things that we've got over there on the left, those are still all being taken care of. No like bases, no zero exponents, no negative exponents. Okay? Let's move to example B. This cubed has got to go to both things that are inside the parentheses, right? So this is going to be 4 to the third, d to the what? 15th times d, and I'm going to put a 1 there because otherwise sometimes we forget that it's a 1. Okay. Now we can start multiplying. What's 4 to the third power? 64. Okay? We have like bases here, so what are we doing? Adding your exponents. 64 d to the 16th. Alright, now, I'm only got about 3 minutes left here, so I want to work through these last 2 together. Ideally, I'd give you some time and then we'd come back and compare, but let's go through this. Okay, I want to get these wrapped up. This exponent of a 2 is going to be distributed here. So I'm going to have 3a to the 4th out in front times. Now, There's parentheses here which are important. What's negative 5 squared? No! Yes! What did you forget? No, you didn't forget negative. You forgot parentheses. Ladies and gentlemen, what's it mean to square something? Multiply by itself, right? I feel like we're back in pre-algebra here. A negative times a negative is a positive. So 25, a to the what? A to the 14th. Now, multiply it together what you can. What's 3 times 25? 75. What's a to the 4th times a to the 14th? A to the 18th, because when I multiply bases, I add exponents. To get 18. Alright, letter D. Now what's the number in front of this? A negative 1. If you want to put that there, go ahead. Times. These each have to be taken to the third power. What's negative 4 to the third power? Negative what? Negative 64. It's not 4 times 3, it's 4 to the third. B to the what? B to the third. Everybody good with that? Now, what's negative 1 times negative 64? 64. What's b to the 5th times b cubed? B to the 8th. Multiply bases. You're going to add your exponents. There's my final answer.